Hello, my name is Colin Doyle. I'm a senior consulting engineer at Juniper Networks. Welcome to the 8th video in my updated Apstra and EVE-NG lab series. In the last video, we got folks pretty much where they would normally need to be for a functioning lab. The videos from here on out are going to deal with some higher level concepts that, I think about it, if you're just testing Apstra and Fabric, you're good right now. The video today is going to cover a different type of interconnection between two fabrics. The videos that come beyond that are going to be videos that are more practical in a production sense. Maybe for testing as well, it really just depends on your resources. We're going to get more into intent and theory and less about copy-paste specific configurations. It's going to be core connectivity, internet connectivity, lots of good information there. Outside or adjacent to the fabric, no less important, but still cool. And then the last video in the series, which is video 11, at least for now, I think we'll do some add-ons later on, but to make this series complete, we'll be walking through some operational scenarios. As I suggested, today's video is going to deal with a different type of interconnectivity between fabrics. The current state that we're in right now, DCA is working, DCB is working. We've got over-the-top DCI that we set up in the last video, connectivity from our testing hosts, between data centers, within data centers, between virtual networks, within virtual networks, everything's hunky-dory. The use case that we're going to explore today for interconnecting these fabrics came to me by way of a customer question. I was at an EDU in, I should say higher ed, probably more appropriate, in the Northeast, and they have a lab where there is nothing sitting between the two fabrics that they are modeling and testing. So we need to connect directly the fabrics, which is fine. Great. Maybe you've got data centers either separated by, I don't know, a row in a data center or geography, and you happen to have a L2 circuit or service of some sort. In these cases, you can just connect the fabrics directly. You don't actually have to have these external routers that you go through. That said, it sets up a little bit differently, and I'll point out where and why it will make sense, but we do need to set this up somewhat differently. In the lab, ultimately what we're going for is we're going to connect the DCA spine 2 and the DCB spine 1. You can scale this horizontally and add other spines and all that. I'm going to do the spines. You could also do the borders. I'm doing it on the spines because we already have DCI on our borders. That's not really a consideration. I just think it's neat to show that we can have DCI on these border leaves. We can have DCI on these spines. In a production environment, your border leaves are generally going to be a different class of device than your access leaves. The same is true for the spine. So if you're going to implement something like this in a production environment, consider what types of devices you're connecting. Consider your subscription ratio that you're targeting. Most data centers are usually 1 to 3. I'm just showing you it can be done on the spine because it doesn't require a VXLAN gateway the same way a border leaf connected to an external non-fabric router would. So I just wanted to show that that's possible. But the configuration that we're going to do today could be implemented on a leaf as well. Let's get started. Step 1, as you might imagine, is creating the link. We're going to just, in our EVE environment here, drag a link between DCA spine 2 and DCB spine 1. It's DCA spine 2 and DCB spine 1 because that way I don't have to run this link through other devices that are in the topology. This is just a nice straight line. So when I built this and I was doing the documentation, sometimes I would step on my own toes because I'd put in like DCA spine 1. That would be a connection that went this way and the line would go through, and this looks cleaner on a screen. You're going to see some pretty familiar workflows if you went through the other DCI video. You might expect that, right? First step, we need to define, because even though Apstra is managing both of these, this fabric is discrete. So as far as it's concerned, this spine is an external generic system. And why not? Right? It's for all intents and purposes It's a different fabric. It's an external thing. So we're going to start by going to DCA and going to staged and topology and going through the same process that we went through when we were building our external connection to this external router 1 from our border racks. And that is to click here, don't mess this up, click spine 2 because that's where we're connecting to, and then click this arrow checkbox and then add external generic. You'll note something interesting here, that since this is a spine, I got different options. That does look a bit different. If I were to click the border rack and click here, it says add internal or external generic system. An internal generic system is like a server, right? It's internal to the fabric. It's connected in through the fabric. The external generic system is the only option you get from the spine because there's no gateway, no VXLAN gateway. So topology, spine 2, click here, and come on, add external generic. Terrific. Okay, let me just catch up on my documentation. Once again, available through the Elevate community thread for this video. We'll say DC-B-spine1. So we're giving it a name that reflects what it's connecting to. You'll see the host name automatically populates. We're going to say this. We're not going to have this represented by that, and we'll click next. And that will bring us to the link page. And like we did with the previous workflow, click and add and create. Fantastic. Also, like the last time we did this, we need to add an ASN. We'll click on the name, go to properties, and then edit this ASN. I know what this is. If you need to check what that ASN is, you can go to staged, or actually, I'm sorry, you go to active. It'll be the same in both places. Go to active and then physical and nodes, and that ASN information will be there. I know what it is already. It's 65200 for DCB. Save. So you say, I remember the last time I was like, did it take it or not? And I had to actually refresh my page. So we will double check to make sure that it took that. And if not, I'll hit refresh. This is an artifact of me connecting and disconnecting from my corporate VPN as it was last time. So the experience is not a problem with the platform as much as it is a problem with me not refreshing Firefox before I start my video. We need to create a different connectivity template. Oh, and there's actually one thing I want to do before we get into anything else here. I'm going to go to Time Voyager, which is where we keep a rollback of all the previous configurations. I'm going to add a description here that says pre-direct DCI commit. Because when I'm done, I'm going to delete the link and I am going to restore the lab. It's only going to be one commit, but I'm going to put a comment here. This is really useful if you're doing multiple commits so that you can sort of track where you're at. And this will allow me to just really easily get back to the state that we were in when we started the video. Pre-direct DCI commits, update. All right, so back to A. We're going to create a new connectivity template. Called the DCI direct. Primitives are going to be pretty much exactly the same as they were when we created the connectivity template for the external system. IP link, say it's untagged. The routing zone is default because we are stitching together the underlay. Our BGP peering is interface. And the routing policy is, oopsie, sorry, something happening in the other screen, external routing policy. You might be wondering, since this is identical, why I don't just reuse the existing one. It is just to keep this discrete from the configuration that is already in place. You could just reuse that connectivity template. It's defined no differently than any of the others. That's not going to be true in perpetuity. As we start to do the core and WAN connectivity, we're going to modify some of the connectivity templates and we're going to switch to tagged interfaces. So this is just, if you're like me, you like to keep these types of configurations discrete so that they don't get confused and conflated and munged together as you start to iterate and operate your network and things start to get more complex over time. It's easy when we're doing these sorts of labs, when they're this simple, to try to just do them in the simplest way. And mind you, a lot of the stuff I'm doing today is pretty straightforward. I do like to try to reasonably connect with what the actual production is going to look like for folks that might be watching this. We're going to assign this connectivity template to that spine link that we just created. And because we are connecting these fabrics together, if I assign an IP address to this interface out of a pool that I've defined, the external link pool, DCA will carve out that /31. When I attempt to assign an IP from a pool, and not even attempt, but if I assign an IP from a pool in DCB, it'll create it'll just use the next /32, 31, the next two IP addresses in that pool. If I set it with a pool on one DC and I set a manual IP on the other, it'll say, I'm sorry, that's already reserved, you can't use it. So what we need to do when we are direct peering is we're not going to use a pool at all. And this is neat because what it also does is it allows me to show you how you can just add a static. The one rule is that you cannot use an IP address that exists within a pool range that you've already defined. So jumping back to our environment, I go to staged, and this is somewhat counterintuitive. So this is just, bear with me here. You go to staged, you go to virtual, you go to routing zones. And we're going to click on the tenant. Wait, oh, I'm sorry, not the tenant, the default. This is the underlay, of course. We're going to click on the default underlay. All of the interfaces that are in use are going to be either in the default routing instance or in the tenant one instance, the VRF instance. From here, we see those assigned IPs, and we, from here, edit them. Now, the reason I say this might be somewhat counterintuitive, if you go to staged, and you go to physical, and you go to interfaces, you will see IP addresses here, and you will have the ability to click and maybe I start clicking around and I click on this address, and all of this is assigned from a pool. You can't do any of that work there, even though it kind of feels like you should be able. This is like maybe the place where you would go for that, or maybe you would go to links. Nope. We go to virtual, we go to routing zones, we select default because we're doing an underlay connection right now. The overlay, honestly, when we get there, it's exactly the same as the workflow for the OTT DCI. We're going to find that interface here. We're going to click the edit button, and from here, we are going to change the IP address. You can see that it's already been assigned an IP out of the pool. And we are going to change that. Scrolling my instructions over here on the left. We are going to tell this connection to use locally 168.168.3. Dot 1 and dot 2 are being used for loopbacks. Dot 3 is not defined within the scope of any pool that we have, so it is safe. We'll give this a 31, and as you might be guessing right now, when we build this exact configuration in DCB, these IP addresses will be flipped so that they're essentially pointing at each other. Done. So now we've got our transit nets. We're going to jump to DCB, and we're going to do some complementary configuration here as well. We go to staged, and this time we click on spine 1, and we click on this box to add an external generic. Make sure that we don't Accidentally write in the wrong device here, which I did the first time I recorded this. This is DCA spine 2, not DCA spine 1. None. Next. We know it's on port 5. We click these to add the link, and we say create. We're going to create our DCI direct connectivity template now. Add template. DCI direct. Stack our primitives for our peering up in exactly the same way. We know that we're using the default routing zone because it's underlay. We're going untagged. We're doing interface peering. And we're going to apply our external policy. Create. We'll assign it to the correct interface. And then we will go to, oh, I skipped a step, forgive me. I do need to add the ASN. I left that step out. So if I go here and go to DC Spine A and properties, I can go to this ASN and I can say 65100. Oh, it's 101, forgive me, because it is the spine 2 switch. Save that. See if it makes me refresh my screen again. Oh, I've been having so much fun with Zscaler today. Let's just hit refresh. It's interesting, if I turn it off, the internet protection, it does, that problem goes away. Come on, there it is. It's such a trivial thing that it seems to only affect this one part of the workflow. I just don't do that. All right, so that's done. You can see everything, even though we had a lot of red, it's all green now. We'll go to staged, virtual, routing zones, default. We'll scroll all the way down to where we see that spine 1 interface. We'll edit it. And we'll put in the reverse of the IP information we put in on the other side. 1/31 for the local, and then it'll be 192.168.3.0/31 for the remote connection. At this point, I am going to commit. And then we'll check to make sure that we see the underlay peering up before moving on to the overlay. Description, direct DCI underlay, commit. I'll jump over to DCA and do the same. Direct DCI underlay, commit. We'll go here and we can sort of watch this come together in real time. Just came up. Look at that. 1 second in. Perfect. Okie dokie. Love it. And we can do it if we wanted to triple check. Show route receive protocol BGP and put in the 168.3.0 neighbor, and we'll see that we're seeing our loopbacks from the other side, which is how we're going to build the overlay. Great. Close this. Move on. If you want to check the loopbacks, I already know what they are, but if you want to check the loopbacks, I'll refresh you on how to get there. Go to active, physical, nodes, and you'll find your loopbacks and IP here. We're in DCA, so we're obviously interested in this. That ASN is obviously the same as well. Even for the underlay peering, the ASN stays the same. The overlay, we obviously were in a different subnet, so we know what that is. And then obviously it's the same place in DCB. We're going to go ahead and build these out. Staged, DCI, OTT, And you might be looking at integrated interconnect and wondering, well, this is integrated, right? You're not actually connecting to external devices, technically speaking. Well, kind of technically we are, because the fabrics are their own entities. Integrated interconnect is for stitching, and that's out of scope of what we're talking about, but still pretty cool. Click on Create Gateway, and we'll call this B-spine1, because that's what we're connecting to. And 192.168.2.0 is the loopback address over there, and 65.200 is the ASN. We scroll down, and we make sure we're assigning it to the correct local spine, which is spine 2, not spine 1. If I keep repeating that, it's because I made that mistake a few times. And then we'll commit this blueprint. Overlay, direct, hang on here. Direct, DCI, overlay, commit. Why not save ourselves a little bit of time by copying that? Commit that, jump DCB, staged, DCI, OTT, and external. A-spine 2. Scroll my instructions here. 192.168. 1.1, 65.101. Locally, this connects to spine 1. Create. And commit. As always, I will pause. No need to make you sit through the settling down of everything, although it does happen pretty quickly. You can see over here, the things are already starting to normalize. If there is an issue, I'll show you what it is. If there isn't, we'll come back and we'll do a little testing. Hold tight, please.
Eating fish.
All right, I'm back and everything's green. It only took a few minutes. It's probably worth pointing out that I paused and I immediately checked the BGP sessions on the spines and they were already up. So I knew that the green was coming. There's been a lag, and that lag is, at least in my experience, a bit exacerbated when everything's virtual like it is here. The point is that it works a lot faster than it might seem when I have to pause and I disappear for 2 minutes. It's all working. I'm not going to go do test hosts, because in order to do that test effectively, I've got to turn a lot of this stuff off up here. And it works. Just trust me, it does. We can log into, say, DC Spine 2, and we can show BGP summary. We'll see the link that we have. It's going to be one of these ones that's obviously not been established for long. We can even guess that it's probably the one that's been established the least amount of time without even looking at the IP. If we do show route receive protocol BGP 192.168.2.0, what are we going to see? We're going to see all the routes that we need to see in order to reach our hosts. See, right here. So we know it's going to work. I'm just not going to put it through the ringer. While I have your attention, though, we're going to go ahead and restore everything. I can do that by going to Time Voyager. You can see that I've got a pre-direct DCI commit. This is the one I'm going to restore. Click that button, give it a second, and commit. There we go. Go with DCB, do the same, restore this, commit the change, go into my Eve topology, right click, delete the link, and we are back to where we started, although we still got this deployment status lagging a little bit. I assure you it will catch up. And there it goes. Fantastic. Thank you for joining me for this addendum to the DCI video. The next one is going to be like I said, more high level, how to connect into your core and WAN. After that, we'll do internet connectivity, and then we will do a operational video. Thanks again for joining me. Hope to see you in the next one. Take care.